Okay, we're going to look at some very simple examples with differentiation. Another word for that is derivative. Okay, so remember that the rule is that you bring the power down, multiply and take one away from the power. So let's start with f of x equals x to the 9, example 1. So if you're differentiating that, it then becomes f dashed x. So you bring the power down, multiply, you take one away from the power, and that's 9x to the 8. Okay, example 2, f of x equals x to the 55, f dashed x. Bring the power down, multiply, take one away from the power, 55, x to the 54, example 3. f of x equals x to the minus 12. Bring the power down, multiply, take one away from the power, minus 12x to the, be careful, it's not minus 11, but minus 13. Okay, example 4. Example 4, we've got f of x equals x to the 8/5. Okay, so you bring the power down, multiply, take one away from the power, so it's going to be 8/5 x to the, well, what's that going to be? Well, we need to do 8/5 take away 1. So think about 8/5 of a pizza, take away 5/5 of a pizza, that's 3/5. So try and quickly as possible get to be doing that in your head. Let's take down an example 5. Let's differentiate f of x equals x to the 11/15. Bring the power down, multiply, take one away from the power. So again, it's 11/15 take away 1, so it's 11/15 take away 15/15. 11/15 take away 15/15 is minus 4/15. 11/15 x to the minus 4/15, final answer. Okay, example 6. We've got f of x equals x to the 5/3. Okay, differentiate, bring the power down, multiply, take one away from the power, 5/3 x to the, well, it's going to be 2/3 because it's 5/3 take away 1, which is 5/3 take away 3/3 of a pizza, which is 2/3 of a pizza. And as quickly as possible, try and get into a situation where you're doing that quite quickly in your head by visualising the fractions. Using pizzas is a good visual aid for that one. Okay, f of x equals x to the 1/4. Okay, differentiate, bring the power down, multiply, take one away from the power, 1/4 x to the minus 3/4, because it's 1/4 of a pizza, take away a full pizza, so it's a quarter, take away 4/4, and that is minus 3/4. Example 8, f of x equals x to the minus 3/5. Bring the power down, multiply, take one away from the power, so it's going to be minus 3/5 x to the minus 8/5, since it's minus 3/5 take away 1, minus 3/5 take away 5/5, which is minus 8/5. Okay, example 9, we're going to differentiate x. Well, let's have a think about this one. You bring the power down, you multiply, you take 1 away from the power. Now, what number's there, even though you can't see it? It's definitely 1, so let's just put that up there. Okay, so you bring the power down, you multiply, you take 1 away from the power, so that's going to be to the power 0. Now remember from National 5 that anything to the power 0 is equal to 1, so that's just 1 times something to the power 0, which is 1 times 1, and that's 1, so that means that if you differentiate x, you get 1. And you're best just remembering that, so you differentiate x, and that gives you a result of 1. Okay, example 10. We're going to differentiate 9. Now, what happens when you differentiate 9 or 5 or 7 or root 3 or pi or minus 0.4 or 0.6? Well, they're all constant values. Now, there's something that happens always when you differentiate a constant. What happens is it becomes 0, so let's just justify that. If you think about 9, 9 can be written as 9 times 1. So that could be written as 9 times x to the 0, because anything to the power 0 is equal to 1. So that's just 9 times 1, which is 9. Okay, now if we then use that rule, so 9x to the 0 is the exact same as 9, because it's 9 times something to the power 0, which is 9 times 1, which is 9. So if we use that rule, you bring the power down, you multiply, you take 1 away from the power. So that means that you would get 0 times 9x to the minus 1. Well, 0 times anything is just 0, therefore you get a result of 0. So example 11, we're going to differentiate root 3. Well, it's a constant, so I barely even need to think about it. You differentiate it and you get 0. Example 12, differentiate 1.2. It's a constant, therefore it becomes 0. Let's try one more. F of x equals pi. Well, it's a constant, so you differentiate it and it becomes 0. Okay, example 14. Let's just make this a bit trickier now. We're going to differentiate the 7th root of x. Now, what we're going to bring into play here is some National 5 work. A to the power m over n is equal to the nth root of a to the power m. So that's not new to you, that's a rule of indices in National 5. A to the power m over n is equal to the nth root of a to the power m. Well, what number is up here? Even though we can't see it, what number is definitely 1. So it's not there in terms of it being presented to us, but we know it's there, and it's a 1. Now, using that rule then, that number goes up top, that number goes down bottom. That could be rewritten as f of x equals x to the 1/7. I can then differentiate, bring the power down and multiply, and take 1 away from the power. 1/7 take away 1. What's 1/7 take away 7/7? And that's minus 6/7. 1/7 to the x to the minus 6/7. Okay, example 15. We're going to differentiate the 5th root of x cubed. Okay, so let's get rid of that root sign and write it as a fractional power. So using that rule again, that'll be x to the 3/5. Okay, so that's just using that rule of indices. Bring the power down, multiply, take 1 away from the power. That'll be 3/5 x to the minus 2/5. Since it's 3/5 of a pizza, take away 1 pizza, it's 3/5, take away 5/5, that's minus 2/5. Okay, example 16. F of x equals the 9th root of x to the power 4. Write it as a fractional power using that rule, x to the 4/9. Bring the power down, multiply, take 1 away from the power, 4/9. X to the minus 5/9. Since it's 4/9, take away 9/9, which is minus 5/9. Okay, example 17. F of x equals the square root of x to the power 8. Now, what number is up here, even though you can't see it? Well, this time it's not a 1. If it's the root sign there, we know a number there. That number up there is 2, so let's put it in just for effect, although it wouldn't be presented to you that way. Alright, so that is the square root, so that's a 2 up there. Okay, so that will be then f of x equals x to the 8 over 2. 8 over 2 is 4, so that's x to the 4. I can now differentiate, bring the power down, multiply, take 1 away from the power, 4x cubed. Let's try another one, example 18. F of x equals the square root of x to the power 5. So again, what number's up here, even though we can't see it? Well, it's the square root, so it's a 2. Let's bring in the fractional power, x to the power 5 over 2. Bring the power down, multiply, take away 1 away from the power. And that's 5 over 2 x to the power, well, it's 5 over 2, take away 1, 5 over 2, take away 2 over 2, and that's 3 over 2, final answer. Okay, example 19, let's just bring in another new dimension. F of x equals 1 over x to the 7. Now, the rule of indices that we're going to bring in this time is this one, the reciprocal rule, which is a to the minus n equals 1 over a to the n. Now, with differentiation, if something's down the bottom of a fraction, we need to bring it up before we can differentiate. So that's going to be, let's bring that up, and what happens, it changes its power. So n becomes minus n, 7 becomes minus 7. That'll be x to the minus 7. I can now differentiate. Bring the power down and multiply, take 1 away from the power. Take care there, minus 7 take away 1 is minus 8, final answer. Okay, example 20. F of x equals 1 over x to the 11. Okay, use that rule again. Bring the power up, so we need to bring that thing up, and that's going to be x to the minus 11. And that's just a reciprocal rule again. 1 over a to the n is equal to 8 to the power minus n. Bring the power down, multiply, take 1 away from the power. It's going to be minus 11x to the minus, it's not minus 10, it's minus 12, example 21. F of x equals 1 over x to the 2/3. So again, bring the power up, change its sign, x to the minus 2/3. Then differentiate it. Bring the power down, multiply, take 1 away from the power, minus 2/3 x to the minus 5/3. Since it's minus 2/3, take away 1, minus 2/3, take away 3/3, that's minus 5/3. Okay, example 22. F of x equals 1 over x to the 7/4. Okay, bring the thing up, change its power, x to the minus 7/4. Bring the power down, multiply, take 1 away from the power. Minus 7/4 x to the minus 11/4. Okay, example 23. F of x equals 1 over cube root of x to the power 4. Okay, so we've got two things to do first. We're going to get rid of the root sign, bring in fractional powers, and that's going to be 1 over x to the 4 over 3. Bring the thing up, change its sign, x to the minus 4 over 3. Now I'm in a position to differentiate. Bring the power down and multiply, and take 1 away from the power. Minus 4/3, take away 3/3 is minus 7/3. Okay, example 24. F of x equals 1 over the 7th root of x. Okay, what number's here, even though we can't see it? The number there is definitely 1. Okay, so two moves to get going. First move is going to be to get rid of the root sign, bring in the fractional power. 1 over x to the 1/7. Next move, bring the thing up, change its sign using that rule. X to the minus 1/7. Now I can differentiate, bring the power down, multiply, take 1 away from the power, minus 1/7 x to the minus 8/7. Okay, example 25. F of x equals 1 over the square root of x. Okay, what number's here and what number's here? Well, if it's the square root, that number there, even though it's not been shown to us, it's definitely 2, and that's x, that's just x to the 1. So let's get rid of the root, and that's going to be 1 over x to the 1/2. Then I'm going to bring the thing up, change its sign, that's x to the minus 1/2. Now I'm going to differentiate, bring the power down and multiply, take 1 away from the power. So it's minus 1/2 take away 1, that's minus 1/2 take away 2/2, so that's minus 3/2, minus 1/2 x to the minus 3/2, final answer. Okay, so you're going to try these ones. Okay, so there's 10 examples that get progressively a wee bit trickier. That is a 2/3 there. Okay, there's another short video coming shortly.